Thanks. Well, thank you, Frank. I want to thank Frank for inviting me and for Credit Suisse for hosting. It's very nice. My name is Tindel. I'm a solution architect at a really well-known, huge company called Previty. Huge, about 30 people now. That's why you've never heard of us. But here's my email, here's my Twitter. If you want to reach out to me afterwards, feel free to take that down. Frank said he wasn't going to invite me unless we gave a really nice door prize away. So we are giving away this quadcopter. However, I noticed when I turned my phone on that I have no internet access down here. So I assume everyone else is in the same boat. So what I've just done is I've extended the raffle. If you want to take note of this URL, info.previty.com/win. Everybody else in the same boat, right? They don't have internet? Okay. So I was going to do the raffle here at the end of the talk, but since you have to sign up to win, I've extended the raffle to be open till 10 o'clock. So go ahead and put your name in after the meeting. I will run the raffle when I get home, and if you win, I'll email you and I'll ship it to you. It's the best I can do. Sorry about that. I'll leave this up for a second. info.previty.com/win. It's really nice. We have a guy at our office who's like really into quadcopters and drones, and so I said, how much for a really nice drone that we can raffle away? So, well, a really nice drone entry level is about like $1,300, $1,500. And I said, okay, what's one step down from that? What's one step down from that? Something that's like small enough you could fly in an office without hurting people. So he told me to get this. It's really nice. You can see the video. The drone has a camera in it. You can see the video from the camera on the actual remote control. I was going to fire it up at my house, but I resisted the temptation. So let me know. I'm going to go on, but let me know if you need that URL after the talk. I'm happy to give it to you. So we are here to talk about security, obviously, in the slide. We moved to a new house last year. We had two little kids. We needed a house. The one-bedroom apartment wasn't working anymore. And so we had to go through this process of finding all this stuff for the house. Of course, refrigerator was one of those things. And my wife said, I want the biggest fridge. And this one is cool. It has this little drawer here where you can, like, you don't have to open up and let all the cold air out of the big units. So I said, okay, this is very cool. And I'm kind of a geek, so I wanted to get a smart fridge, something which internet connected and it's digital, and I can look at stuff from my cell phone, and of course you need to do that from a fridge. And this fridge is really nice. It knows what food is inside of it, so it can give you recipes based on what food is in there, and you can link up when your milk gets low. You can just order more stuff from Fresh Direct and all that. It's very, very, very nice fridge. It's nice. It was nice until people hacked it and used the web server that was embedded inside of it to send out spam from people's houses. All right. So yeah, this smart home Internet of Things is very, very nice, but it creates new opportunities for hackers. And the thing with security is that security, anytime you read about it in the news, it's a sexy problem. Your refrigerator was hacked. That's a sexy problem. Anytime you watch a show like Hackers, there's a three-dimensional file system that the hackers are navigating, and he's hacked my Gibson, and I need to get up the firewall, and he's in the middle of my TCP stack, and it's very sexy when you see it on TV. But in reality, it's not anywhere near that sexy. It's like looking and pinpointing and looking for little buffer overflows you can write, and someone who's not checking their input quite right. And from a programmer's point of view, it's very, very unsexy. And that's why a lot of programmers try not to deal with it. Right? That's why we end up having a lot of security vulnerabilities out there, because it's kind of boring to sit there and I just need to double check every parameter that was submitted to my web form and make sure there was nothing improper in it. It's kind of boring. And so we end up with all of these hacks that we see in the news. Of course, this was a hack where a smart TV, basically someone was able to remotely turn on the webcam in the smart TV and they could see in your living room. All right, that's very sexy. These things just happen all the time. Just 2 weeks ago, someone hacked the Chrysler Jeeps and figured out how to remotely turn off someone's Jeep while they're driving down the highway. And this was big, big, big news 2 weeks ago. That's a huge problem. Huge problem. And not that I'm one to, rely on toilet humor to make people laugh, but there was a smart toilet that was hacked. All right. So nothing is safe. Nothing is safe. You have to be very, very careful. So we're going to talk about a little bit about the evolution of security and kind of how it's changed over time. Of course, we have these enterprise apps. Enterprise apps are monolithic typically. Even if they're written in microsites, there's hundreds and hundreds and hundreds of microsites. in them. So they're complicated. They're written in dynamic languages. They're written in static programming languages like Java or like C, C++. They might be written in dynamic languages like Ruby or Node.js or one of the many scripting languages. They're deployed to clouds. They're deployed on Big Iron. They're deployed in virtual machines, all of which have different operating characteristics. Okay, we like to say that they're the same, but they are kind of different. Okay, so they're just complicated, and getting your hands around what security means is not just one question you have to ask. Security is done in layers, and it's done at every layer of the stack, and some tools solve some problems and some tools solve other problems. So there is no one tool that solves everything. All right. So we look at these in stacks, and we talk about network security, which is firewalls and things like of that nature. Okay, I might call it the perimeter security. So big companies are really big about defining a perimeter. Right? They have the things inside the company and they have the things outside the company. And even then they might have multiple layers of things. Right? As you make your way in from the web server to the application server to the database server, those are all different ratings of security. But that's this idea of network security or perimeter security. All right? We have endpoint security. So this is making sure that your operating system is patched and you have the most recent kernel and you're not subject to the most recent OpenSSL vulnerability that happened recently called Heartbleed. Okay, so there's lots of systems. People are spending millions and millions of dollars to buy the McAfee tools that make sure that your operating systems are patched and things of that nature. All right, and then the new layer of security that people are starting to pay attention to is called application security. So this is actually making sure that the code of the application itself is protected. And what people have been doing here recently, there's tools called SAST, which is a static application source code scanner. There's tools called a DAST, which is a dynamic application source code tool. And a SAST basically, if you're old school like Frank and you've been around since the 70s, I'm sure he's used lint and tools like lint that go through your source code.
Never heard of it.
Yeah. Yeah, and it goes through your source code. So static tools go through your source code statically before they're compiled and just look, is there anything that looks like a buffer overflow? Is there anything that looks like you're using a variable before having initialized it? Things like that. That's what a SAST does. A DAST is a black box testing. So whereas a SAST is white box testing, a DAST is black box testing. So you can take a DAST and point it against your website, and it will load your website and say, oh, I have all these forms. Let me just try putting things into these forms and see is there a SQL injection vulnerability? Is there a cross-site scripting vulnerability? So there's a number of DAST vendors out there. Veracode has a DAST. White Hat has a DAST. So there's a few out there. IBM has a DAST. All right. But the problem is that these tools might find vulnerabilities for you. You get a nice report. So here's 1,000 vulnerabilities in your application. Now you got to go fix 1,000 vulnerabilities. All right. You're still not safe until you fix the problem. And that's the main idea here. Now, we talked about, Frank mentioned it, where the clouds the lines are blurring, and here we talk about, you just kind of have to assume that a hacker is inside your network at some point. If you really want to be safe, you have to assume that a hacker's got in. You can't just say, oh, well, anything beyond this line can just do whatever it wants, right? And it's the wild open west. But what Google did was they said, we're actually going to take this whole new approach and say we don't have internal Google servers and external Google servers. Right? They're basically just saying all of our corporate applications, which used to be on our so-called intranet, are now just accessible to everybody via the extranet. All right? That's their plan. That's what they're trying to do. And they're trying to eat their own dog food and say, Google Compute Engine and Google Cloud Platform and all of that, they're just going to take all of their corporate applications and run them there. So, well, it's nice because it makes us just assume that hackers have access to our application, so now we have to be really careful when we're programming things. It also makes it very easy for our employees all over the world to work from home if they want to do that or whatever. They don't even need a VPN anymore because they just access these things over the public internet. All right, so that's extreme. That's the only big company in the world who's even talking about doing anything like that. But I do think that Google's a thought leader, then maybe that's where we're going. Okay. Defenses haven't scaled. Volumetric defense is basically something that defends against a denial of service attack. If someone's attacking you with just a volume of requests. So my friends used to run the Tumblr infrastructure before Tumblr got acquired by Yahoo. And when I joined Previty, I asked them about this denial of service stuff and how they deal with it. And he said, yeah, we just had to shut off. We would get denial of service attacks, or one time would have shut off whole countries from accessing Tumblr for like a day or two until the botnet calmed down. And he said one time we had to shut down all of Europe, which is nobody in Europe can access Tumblr until this thing stops. Right? And that's just, I mean, that's what it is. That's the reality of it. There's only a few networks in the world that could absorb a denial of service attack. Amazon Web Services can do it, Google can do it, Microsoft can do it, Akamai can do it. I mean, there's maybe like 5 in the world that could do it. Right? Otherwise, you end up just shutting off countries when it happens. You have these web application firewalls that people are installing, and what they do is they inspect the traffic on the way into the web application, and if they see something that's malicious, they turn it off. All right? So they're looking for people trying to submit JavaScript into your application. They're looking for people trying to submit SQL injection attacks into your application. We're going to talk about what all those things are. So if you don't know what that means, don't worry, we'll talk about it a little bit. But the point is, these WAFs, basically at an underlying level, are just complex pattern matching tools. They just have hundreds and thousands, not hundreds of thousands, but thousands of regular expressions that they run every time something comes in, looking for something that might be JavaScript. That's how they detect cross-site scripting. Looking for something that might be SQL injection. That's how they detect SQL injection. So it's all based on pattern matching. And once you define a static set of patterns that you're trying to match against, it's possible to sort of weave your way through those patterns. We call that fuzzing. So you can Google fuzzing if you want to see. I'll show you a fuzzing tool, and we'll look at an example of that. All right. Now, depending on who you ask, right, there's lots of different numbers out there. 84% of attacks in 2013 were targeting applications. So botnets are out there. People know how to deal with them. You know, if you're a professional IT administrator and you're running a big site like Tumblr or Yahoo or Google, you know how to deal with denial of service attacks. They happen all the time. I mean, I guess if you work for Sony, you don't know how to deal with denial of service attacks. But everybody else, they know how to do it. So this is the focus moving forward. All right, is attacking applications themselves in some way or another. All right, this came out of HP Protect. Of course, HP has their own static and dynamic source code scanning tools called HP Fortify. They acquired a company called Fortify a couple of years ago. So 90%, and they just know this because they have all this telemetry from the thousands and thousands of customers that run HP software and that run their source code scanners, and they can get sort of anonymous reports back from their tools, and they just know 90% of their apps out there have at least one critical bug that hasn't been resolved. Right? These tools come from them. There's also for HP Protect, from the time that their tool identified a SQL injection vulnerability in an application, the average time to fix it was 138 days, like a third of a year, 3 or 4 months. That's a long time to have an open vulnerability on the public internet. Someone will find it. And I don't know if you've ever just turned on firewall monitoring at your house to see what happens on your cable modem at home. It's really interesting. It's really interesting. There's just Chinese IPs just hitting you like all the time. All the time, scanning port 22. So it doesn't matter what IP address you're running on, someone's scanning you basically all the time. And so now we have these controls that are evolving, whereas before we had network and web firewalls, now we're moving to this micro-segmentation. We're moving to micro-virtualization. Okay, this is Docker, right? Like Frank said, it's very sexy. We were using SAST and DAST and throwing people at, basically throwing bodies at it. That's why you have these IT companies that just make millions of dollars for doing basically remediation of the vulnerabilities that are found by these scanning tools. It's expensive to go fix a remediation backlog that has thousands of things in it. All right, also, you don't know where to start. Let's say you're a big company like Credit Suisse, and you have 10,000 enterprise applications, and they all have vulnerabilities. So which one do you start remediating first? Do you start with the one with the most vulnerabilities? Do you start with the one that, if someone asks you the question of which applications are actually under attack, you probably wouldn't even be able to answer the question based on tools that we haven't had until now. And so this new category is called Runtime Application Security, Runtime Application Self-Protection. That's what we're here to talk about tonight. All right, RASP, R-A-S-P is the Gartner term for it. Right, it's not my term, I didn't make it. But if you Google RASP, you'll see there's various RASP vendors out there. Brevity, of course, one of them. HP has a play in there. There's a couple new companies coming out. Contrast Software is getting in the market. And we'll talk about some more open source stuff that's out there as well, so that you have some things to play around with afterwards if you want. All right? There is an organization out there called OWASP, and they publish what they refer to as the OWASP Top 10. Changes every couple of years, here and there. The three things that we're going to talk about tonight are SQL injection, cross-site scripting, and cross-site request forgery. Depending on who you ask, these three vulnerabilities account for like 97–98% of all the vulnerabilities of web applications every year. All right, so this is a quote from Barclaycard. 90% of data breaches that they've heard of were due to SQL injection. Symantec says that cross-site scripting was 84% of all security vulnerabilities that they documented. Here you see the cross-site request forgery attacks increased 132% in 2012. So these things are happening, all right? So, of course, there's things like security misconfiguration. There's things like broken authentication mechanisms. These things OWASP documents. There's not too much you could do about them except to say just go fix them. But there's no, it's hard to have a tool that like understands that your security is misconfigured. This is just a people problem and you have to fix it. But these, using known vulnerable components, I mean, okay, what do you got to do? You got to change your software so that you're not using things that are vulnerable. All right, but these three things are where products like ours or like HP's or whoever's can actually help automate these fixes, and those three are the three big ones. Anyway, all right. New attacks beyond the OWASP top 10. New attacks are found all the time. This was just in May, an attack called Logjam. Right. This is basically what we call a cipher downgrade attack. So when you go through a Diffie-Hellman key exchange, there's things like, you have to worry about things like key sizes, and not to get too technical, but basically what happens is, with Logjam, it's possible when you do this to act as a man in the middle, and instead of using, let's say, a 2048-bit key, which would be very strong, to force the SSL negotiation to downgrade to a 512-bit key, which is actually easy, which makes it easier for a man in the middle to act as a man in the middle without either side knowing. All right. So Logjam is a new vulnerability. Basically, in order to fix it, people have to upgrade their SSL implementations. Again, it's kind of like Heartbleed, right? Which probably means on the Java side, upgrading to a version of the Java runtime that has a fix for it. And so these things are coming about all the time. Of course, I'm sure you heard of Heartbleed. So we're going to talk about what those three main OWASP top 10 vulnerabilities. I'll go through what those are so everybody understands them. This is not like a really deep, you really have to be a Java nerd to understand what's going on here. But we are going to use Java code and look at how to fix these things. So a SQL injection, for people who know SQL, is you tend to use statements like this. Select star from users where user ID equals some user ID. You're going to fill that in with the user ID that someone typed in. So my username is Tindel. All right. But what happens if I supply the username Tindel or 1 equals 1? Well, the string 1 equals 1 is called a tautology. Tautologies, just like in mathematics, tautologies are true by definition. Right? 1 equals 1 is true by definition. So if I say where user ID equals Tindel or 1 equals 1, that statement is going to match every row in a table. All right, so these types of tautology attacks are used for what we call data exfiltration, is getting a lot of data out of a server. If I'm able to match every row in a table, maybe I can make that dump to my screen somehow, and then I can see all the usernames that are in the table. Maybe I can see their hash passwords. I can maybe see all kinds of stuff. So you have to be careful when you're taking input from a user and shoving it into a SQL query that's going to execute in your database. You have to be very, very careful. There's lots of different ways to form tautologies. This is a very simple one. It's kind of the canonical one. You'll see 1 equals 1, A equals A, or 2 equals 2, things like that. But there are more complicated tautologies. 3 equals 2 plus 1 is also a tautology. And while it is easy for you and me to look at that and say, hey, yeah, of course, 3 equals 2 plus 1, yeah, that's a tautology. But if you're trying to find these things with regular expressions, that's really hard, because that's actually a mathematical expression that has to be evaluated. You cannot really find those that easily with regular expressions. So if you write a regular expression that looks for this, which is what WAFs do, you're always going to miss something that looks like this, and of course you can get really complicated sine of 0 equals cosine of pi plus 1 is also a tautology. All kinds of different ways to form tautologies inside of a database. All right, most of which are difficult to find with a regular expression or pattern matching. All right. What if I did this as my username? My username is Tindel, semicolon, drop table users. subject of a very famous XKCD article. Bobby Tables, little Bobby Tables we call him. Yeah, thanks, we dropped all our student records in the database. I hope you're happy. And I hope you've learned to sanitize your database inputs. All right, exploits of a mom. It's classic, the internet loves it. There are a number of ways to protect against SQL injection. The primary ones being prepared statements, where you basically tell the database this is what my statement is, and I'm just going to tell you, hey, execute that statement and fill this variable in. All right, so this is how you do it in Java. Basically, you create a prepared statement, and you get the parameter from the request object, okay, and then you say execute the query. So I'm not going to go deep into that, but the point is, you need to be using parameterized queries, or you need to be using stored procedures. These are the two primary defenses for SQL injection. Every major database has the idea of something like a stored procedure, and all modern applications are doing this. I guarantee you, if you work for a big bank in Manhattan, and you're writing Java stuff that interacts with databases, you're using either stored procedures or prepared statements or both. You're using it. But there are legacy applications that were written 10 years ago that may not have done this before everybody knew that this was the way to do it and that this was sort of a good habit to get in. And so there's just all this legacy code out there, and that's why you see those other stats about so many open vulnerabilities with SQL injection. If people were doing this, there would not be that many open vulnerabilities with SQL injection. So what does that tell you? People aren't doing it. All right? It's easier to just say, well, I have this string, and I'm going to, no, this one, sorry. It's just easier in your code to say, well, I have this string, and I'm just going to add another string to the end of it. It's just easier. And when you're under a deadline, and you have a lot of things to worry about, and you're just trying to get things done, and it's 2 in the morning, and things aren't compiling right, you just kind of, you'll take the easy way. Not everyone, I'm not saying you, but, you know, the larger you. Many people will take the easy way, and that's why we end up with these vulnerabilities, all right? Because it's kind of, like I said, it's not sexy. There's no three-dimensional file system here. It's just setting up prepared statements and doing stored procedures. Okay, that's how you do it. All right, the next type of vulnerability we talked about, cross-site scripting. This was a huge problem that came about in the MySQL days, I'm sorry, in the MySpace days. All right, our CTO and founder was actually in charge of security at MySpace when MySpace started and for a number of years. And so he just dealt with this problem a lot. And at the very bottom of what cross-site scripting is, it's JavaScript. So when a website serves up a page into your browser, they're allowed to run scripts in it. And most modern websites have some JavaScript in them. It wouldn't work right if you had JavaScript turned off. Those scripts have access to variables in the browser, and they have access to cookies. And those scripts can do things like go out to other web pages and hit other URLs and things like that. So if you're let's say you're writing a web page that allows people to submit content that gets reflected back to other users. So you are writing a blogging application, and part of that blogging application is the ability for users to leave comments in that blog. Well, if one of the comments that someone leaves has the script tags around it and has JavaScript in it, then, and you don't clean it up, you don't do anything about it, then when you save that in your database and someone comes and hits your site and you want to render that comment back into the HTML, which is going to be in that user's browser, that means that arbitrary people are going to be running JavaScript in your user's browser. That's what cross-site scripting is at its core. Okay? So there's a couple ways to do it. There's something called reflected XSS, which means that a parameter, let's say a parameter that you put inside of a URL, query parameter, ends up back in the HTML that comes back to you. Okay? And if you don't sanitize that, that's going to be what we call reflected XSS. Stored XSS is the example I talked about first, which is where you actually end up storing the XSS in your database and basically reflecting it back to other people. All right. So there's lots of different ways to do it. So here's the simple version. This is a script tag with an alert statement inside of it showing you someone's cookie. Here's where I'm closing another tag that someone else had, and I'm inserting my script tag inside of it. Here I'm using URL encoding, so I'm using %3c instead of the less than sign. Here I'm putting a script tag inside of another script tag. All of these things, here I'm using an alert inside of someone's body onload tag. So the onload tag is allowed to have JavaScript inside of it. The Onmouseover tag is allowed to have JavaScript inside of it. So lots of different ways to hide this JavaScript inside of HTML, and you probably don't even know it's there. All right. It's hard to write, again, just like with the SQL injection side, it's hard to write regular expressions that catch all of this. It just is. There's just so many different ways that different browsers, IE, Safari, Firefox, Chrome, they all parse this stuff a little bit differently. They all interpolate things into the DOM a little bit differently. All right? And they're constantly writing new versions at that. Right? So Windows 10 came out today, and there's going to be a new browser as part of that. IE 11's coming out, and they're all just doing this stuff differently. All right? And on top of that, there's constantly new kinds of JavaScript coming out. So JavaScript 6 is coming out now. So we had 5, ECMA script, all of this stuff. It's just an ever-moving target to try to find it all. It's hard. All right, so we talked about stored and reflected XSS. DOM-based XSS is the third one, which is basically someone modifying the DOM inside of the browser. So it's not what's coming back from something that somebody else submitted. That's probably the most confusing one to try to explain. And no one's found a solution to it yet. There is no known solution to find DOM XSS. So all of the tools that are out there today are out there to try to automatically detect and prevent stored and reflected XSS. Now, we have some programmers in the room today. I'm just curious if anybody can tell me what this string would be interpreted as inside of a browser. This is valid code. This is valid JavaScript. Of course you can. Of course you can. But this is valid JavaScript, which basically gets interpreted by a browser as this. Not kidding. These are identical JavaScript code from a browser's point of view. And basically what it is, it's just a bunch of conversions of strings and what's the term when a compiler converts something to something else? I'm just blanking out a term. Translation. What's that? Yes, there's a. What's that? Nah, there's a. I can't think of it, but. What's that? I'm sure it'll come to me in the middle of the night while I'm sleeping. It's an implicit conversion. Basically, things get implicitly moved from, say, 0 to null or things like that. This is what's going on here, and it does get converted to this inside of the browser. And if you want to I'll just show you an example really quick. There's a tool called JJencode, which does this. And when I talk about fuzzing, this is what I'm talking about. So if I were to say, yeah, sure, hello, Frank, all right, this code says hello, Frank, in the browser.
We can't say anything.
Oh, yeah, I'm sorry. Yeah, let me move this over. Sorry, I thought I was mirroring it. I didn't realize it was separate. Okay. Yes. So I put in hello, Frank here. The tool generated this code. And if I ask it to evaluate it, yeah, it does in fact say hello, Frank. All right, and it's popping up with JavaScript. Now, finding a regular expression that will detect this, I mean, it's basically impossible. It's not impossible, but it's basically impossible. And then, just to make it really cool, the tool allows you to say, actually, I don't want this. I want you to turn this thing into a palindrome. So a palindrome is the same forwards and backwards. So you can see here it starts with a quote and then a single tick and then a backslash. And if we go to the bottom, it's got a quote and then a single tick and a backslash. And it evaluates the same way. So it's this really cool tool. We like to use it in our lab to try to fuzz around things. JJencode, it's just so easy. And you could just see, you could just imagine how hard it would be to try to find this with a tool that does pattern matching. It's basically impossible.
I think if you look for more than, say, $10 signs, you're probably good.
Well, maybe. Maybe. It certainly would be suspicious. But then what happens when you deploy these WAFs inside of your environment? The WAFs have two modes. There's a passive mode, which says just kind of look for stuff, look at everything that's coming in, but don't ever change anything. Don't change the behavior of my application. Don't end any requests. Just sort of pass it through transparently. Sometimes they call it transparent mode. But then notify me if you see anything that's weird, so I can go look and see what's going on. You're right. Looking for $10 signs would certainly be a good thing. But you don't know. Maybe that would break something else. Maybe you want people to submit regular expressions into your app for some reason. who knows, maybe you're looking, maybe it's like a big table with a bunch of currencies and there's like hundreds of dollar signs in it. You know, you could break real functionality by turning off stuff that isn't actually JavaScript. And so that's what happens when people turn their WAFs into active protect mode, their applications just break. And so they have to go through this constant, like every week they go through for every application that it's enabled for, and they retune their WAF, saying what broke, how do we fix the WAF so that the valid traffic that we want to let through, that it's saying isn't valid, does get through. So it's just a constant retraining of the WAF every week. It's a lot of work, and that's what people are doing right now when we talk about this network protection. But it's hard because it's all based on this pattern matching stuff that if you do it wrong, you end up, not only do you end up with ability to fuzz through the patterns, but you generate a ton of false positives, and so there's a lot of noise. All right, yeah, so JJ code, very cool. The primary defense of this is to just never insert untrusted data directly into any script inside of your website, into an HTML comment, into an attribute name, in a tag name, directly in your CSS, all right? Just certainly never accept JavaScript code from the outside and putting it from an untrusted source and running it inside of your application. And when you have to take untrusted data, of course, there's no way around it. You have to take people's login names and their passwords and their email addresses and things when they sign up and everything else that your application wants to do. You have to store that somehow in your database, and you have to be able to show that in a website safely. And so you have to encode it somehow. And so that organization I was talking about earlier, OWASP, that published the top 10, they run this open source project called the Java Encoder Project. And they just shipped the newest version, I think, in April. It's out here at this GitHub account. And so as a Java programmer, when you're writing websites, you can take their open source stuff, and basically every time you need to take a parameter that you want to put back into your HTML, let's say you want to take the user's name and you know, put it up on the, you know, say on the top of the nav bar or something, so they know what their username is. And that's going to go inside of a div tag. So you just call this encode for HTML function. This SAPI is the name of their library. You ask the SAPI encoder, please just encode this parameter that I have safely for HTML, so that, and then it'll encode it in a way for HTML that it's basically not going to be interpreted by the browser's JavaScript. And then you have to, but there's different types of encoding that you have to do depending on where in your page you're going to put that untrusted data. So this is what you do if you're going to put it inside of a div tag. This is what you do. There's a separate function, encode for HTML attribute, if you're going to put it inside of an HTML attribute. There's a different one if you're going to take their thing and put it right inside of your JavaScript, okay, encode for JavaScript. And so this is how you sanitize untrusted data to prevent cross-site scripting. All right, it requires you to change your code. This method requires you to change your code so that the stuff is sanitized. Any questions? Yes? Have I heard of App Vault? I haven't. Do you know what it does?
Well, apparently, it basically is like it encrypts. I guess it's whenever HTTP does encryption, it creates a secret key. So that's that back and forth between services. It encrypts it, but then I guess it's like another service. So once it passes through, it decrypts it.
So it sounds like it's sort of automated encryption between two services that maybe, yeah. I mean, like I said, there's so many different vulnerability points inside an application that no tool can solve everything, and you can't just buy one tool. You do need a WAF to solve denial of service attacks. You need this tool to deal with untrusted data. You need another tool to deal with encryption. You need so you just end up having a lot of tools. There's no way around it.
With microservices, how would you was talking about earlier, have multiple services and make calls, and you have all these connections being established. Is it just like you just have to just try to cover as many fronts as you can?
You have to cover all the fronts. You have to cover all the fronts, but you know, these microservices are designed so that they have a contract in front of them, right? They basically are putting up an API, whether that's a REST API or some other API, and saying, you know, if you want data from me, give me some input in this form, and I'll give you data back in that form. Right? That's how microservices work. Well, that's how all service-oriented architectures work. But they're typically written so that they don't have trusting each other. That's how you say, well, I'm not going to just trust the input that comes from that service. I'm going to double check all the input that comes from that service, and I'm going to sanitize it. And every service needs to be doing that, basically not trusting the other services. That's how you end up with these very nice secure. That's what makes those architectures more secure. It's easier for a team of 3 people who writes this very small thing to understand all the code in it, to look at every line of code where they're dealing with input and make sure it was sanitized properly. That's the advantage to having small teams and having very, very small microservices. It makes it easier to code review. Yeah?
How often do you see people do security within the JVM, like within the Java codes?
You like this?
No. Just like if one class calls another, whether or not it has permissions to call, and so on.
Oh, I never see that. Yeah. Yeah, inside of the JVM is totally a separate environment than 2 external services like talking to each other. I mean, I'm not going to say never because I don't know everything about Java, but usually inside of a JVM, you're sort of trusting other classes. I don't know if there's a good way around that. Yeah.
I believe with respect to stored procedures, it's not going to be safe to avoid SQL injection because based on how you use the parameters injected into the stored procedure, how they are used, could cause SQL injections.
Yeah, I'm not saying it's perfect, but you still need to do it. Yeah.
And the other thing is with respect to even using parameterized queries, you need to be careful how you form those statements out there.
You have to be careful. Yeah, I don't argue with any of that. It's not like it's just going to solve the problem right out of it, but
because I've seen people use parameterized query, but they still do string concatenation.
yeah, sure. You know, you have to be careful with how you're doing it still. No question about it. I agree. All right, that's XSS. So cross-site request forgery. Don't want to go too deep into this one, but this is basically the idea of, think about how when you go to a website, you're already logged in, and that's because they stored a cookie or they stored some sort of token or they stored something, maybe a JWT inside of your local storage inside your browser, something like that. Well, imagine if there was a way that someone could send you a link that you could click that would basically cause you to go to another website and do an action that has a side effect. The examples you always see is if you could click a link and like transfer money from one bank account to another. That's not really realistic, but that's like a textbook example. But we all know things like. But this is why you never write an HTTP GET request that has a side effect. All right, because a GET request can be submitted by a link, which someone could send a phishing attack out an email, and people click this link thinking that they're going to their bank when they're really going somewhere else. And anyway, so CSRF attack is basically a way of attacking someone who's already got credentials to a website, and you're going to make them do something on that website based on the fact that they're already authenticated on that website. The cross-site request forgery. All right. The way that's usually fixed is via using these unique tokens and things inside of a session cookie that expire. It's why when you go to your bank's website after 10 minutes, you're automatically logged out, and someone can't just send you something and say, oh, you were authenticated to your bank 24 hours ago, and that authentication is still valid. You have to use these, whether it's a hidden token inside of a form field or something inside of the cookie that expires after 5 minutes or 10 minutes, that gets validated on the server side for expiration. You have to use something that's a uniquely generated token that expires at some point. All right, it could be stored inside of a form, it could be stored inside of a session cookie or something like that. But it does need to be validated on the server side that that thing is still valid, that it hasn't expired yet, right? And that it was actually for that user. So we call these tokens. Okay. There is, like I said, there's no silver bullet. We already talked about WAFs having a high degree of false positives. We talked about the difficulties in pattern matching. Developers are continuously building new products and features, and to the point where they have continuous integration. So even if you had, let's say, a really, you had a very mature, what we call secure software development lifecycle, SSDLC. Let's say you had a really mature software development lifecycle that made sure that all of your applications were going through a SAST, and all of them were getting tested by a DAST. and that generated a remediation backlog that someone came around and fixed on a regular basis. If you're in a model where you're developing software, you're doing continuous integration, you're in an agile environment. I mean, we have one customer that releases their website 20 times a day. All right, almost once an hour, and that's becoming to be not so extreme anymore. That's for a bank or something that would be extreme, but for websites like let's say like Etsy.com or Tumblr or health insurance, there's a cutting edge health insurance company here in New York called Oscar.com. You've probably seen the ads in the subway. They're based here in New York. They're just releasing their websites all the time. So if they release something that has a vulnerability, even if they have a very mature process where they have a scanner that finds it and someone else comes to fix it, there's this, we call it a remediation gap, or the remediation window, where for 30 days or 60 days or 90 days, there's a vulnerability until someone fixes it. All right? That's a problem. That's a problem, even with very mature processes. So there isn't really a scalable solution to defeat the vulnerability backlog. I mean, it does just involve like throwing a body at it and saying, go fix this code, right? And test the code, make sure you didn't break anything, make sure deploy's okay, make sure you get it deployed and live. That takes people and time, and those things are money for corporations. So there's also really no good real-time visibility into attacks that are happening on your website. So if you're using those SAPI libraries we talked about, and you're using them properly and using them everywhere, you're probably good. You're not going to have the nature of the attack happen, but you're not actually going to know if someone is attacking you, and who that person is that's attacking you, and what part of your website they're trying to attack, which applications in your data center are actually under attack. All of those things you would like to know. So we need to have a solution to that problem. So that's what RASP is. I know I introduced that term earlier. It's a Runtime Application Self-Protection. The idea that there's protection features built into the application runtime environment itself. Not necessarily just that your code is calling these functions, but that the environment that your code is deployed in, whether that is the JVM itself or something else, I mean in this case it is the JVM, has protection built in. So that even if your code has vulnerabilities, the surrounding environment of the application container will protect you. All right. You don't need to read all this, but Gartner did publish, you can just Google Gartner RASP if you want to read it. It's out there. So there's some open source stuff that's out there. There's a product called HDiv, not a product, a project called HDiv. And if you're a Java programmer and you happen to be using one of these 5 frameworks, Spring, JSF, Struts, etc., you can take their code and just add it as a plugin into your application, and they will automatically apply those, just like those same functions that we talked about with the SAPI encoding. When requests come into your application, HDiv will automatically apply those types of encoding, okay, to things that you're using. All right. Now, that's great if you happen to be using one of these 5 things. But if you're not, there is a company called Waratek, W-A-R-A-T-E-K. And so they're Java focused. They have created their own version of the JVM, which is instrumented in all these interesting ways to prevent things. So it's a commercial product. It's not my product. I'm not selling it. I've heard it does work well, but only if you're using Java. Right? They don't have a product if you're using .NET. They don't have a product if you're using, say, Ruby on Rails or Node.js or anything else. So there is a commercial product called Waratek. You also have to be willing to use their JVM. Okay. It's not something that you could just use the Oracle JVM and plug them in. They have created an entirely new JVM that you use instead of, say, the Oracle JVM. All right. But it is out there. I've heard it works okay. HP got in the market of RASP. They have a project called App Defender. They're basically taking their DAST and SAST and their IaaS tools, which basically write Java agents. If you know what a Java agent is, when Java 1.6 came out, they created this thing called the Instrumentation API. And it allows you to go into someone else's code and sort of wrap functions. So you say, before this function is called call my function. After that function is called call my function. Okay, so these tools, which you'll hear called IaaS tools, basically go into the application side itself and wrap every function so they know when things are coming in. They can see variables as they pass through the application. They know what functions it was passed to and which line code, which source code and line number it was on and all of that. And so they can do all this tracing through your application. It's interesting stuff. It works. It's very, very slow. I've never seen anybody deploy something like this in production. Just the nature of, say, trying to instrument every single function in your application. It's slow. It's okay in testing. It's fine in testing, of course, but it is slow. But what's nice for us, Previty was the first RASP vendor in the market, and I mean, we're only 2.5 years old, so I'm not saying like we've been here a long time, but we were the first vendor in the market, and so what's nice having HP jump in is it sort of validates the market. All right, there's a huge company that's investing resources there. It means that this is a real technology and a real space. All right, it's nice to have competition. This is my little commercial. Frank said I could do like 3 slides at the end and just tell you how Previty works and how we're different. So what we do, we're a polyglot, so we ship SDKs, just like there's the SAPI SDK for Java. We ship SDKs for all the major programming languages, Java of course being one of them, C#, Node, Go, PHP, Python, etc. And so we provide those same functions, just like we saw encode this variable for HTML, encode this variable for JavaScript, and we provide you functions like that. We provide you a function that says, check this SQL query for tautologies, all right? Check this SQL query for, you've basically set up a policy that says what your SQL queries are allowed to do or not to do, and you can say validate the SQL query against those policies. So basically that's an SDK, and so if you're writing a program and you're able to go out and change your source code to call into our SDK, that's great. You can use our stuff. Now the problem is there's these thousands and thousands and thousands of legacy applications out there which there's no development around anymore. The developers who wrote it are long gone. Maybe it was written by a third party. You don't even have access to the source code. So if you're in this situation where you don't have access to the source code, what do you do? So that's what we did. We wrote plugins. So where a language like Java has a standard framework, which we call J2E, or a language like C# has a standard framework, which we call .NET, or you have Django on top of Python, or Rails on top of Ruby, these standard web application development frameworks provide hook points where our plugin can sort of hook in and say, well, all the HTTP requests that are coming in are going to flow through our code first. Every time the application wants to run a SQL query, we can analyze it first. So it's not like the IaaS tool I was talking about before where every single function of our thing gets wrapped with our code. Very specific things get wrapped with our code. All right, so in Java, and if you know anything about J2EE, basically you have a request response lifecycle. So an HTTP request comes in from the browser sends an HTTP request to the server. The server handles it somehow, and then it generates an HTML response, and that response goes back out to the browser. So there's something called a filter. In the Java EE parlance, they just call it a filter. And just like in Unix, or like the stuff that Frank was talking about earlier, it's a filter chain. So the request comes in, the first filter does something, it can transform things, it passes it to the next filter, it passes it to the next filter, and so on. And eventually, one of those filters either says, okay, here's the response, or you get all the way to the end, and the framework says, okay, here's the response. So we have a filter that basically handles all of the inbound traffic coming from a user and can detect cross-site scripting attacks. When an application is going to go run a SQL query, we trap that call, and we send it. We're calling these underlying SDK calls automatically from the plugin. All right, that's how our stuff works. Now, when we detect something, we're able to fire off something into your SIEM, which is an event management tool. You might use Splunk, you might use HP ArcSight, you might use QRadar. There's tons and tons of SIEM, not tons, but there's a number of SIEMs out there that people are using. And so when we detect something, we can fire that off into your SIEM to let you know, not only did we stop this attack, but here's, basically, we can identify the origin of the threat, we can give you the natures of the threat, so who is the IP address? And maybe you want to take that IP address that we told you would just attacked you and feed that back to your firewall, so that your firewall just filters out that IP address for the next 24 hours or something like that. All right, probably don't want to do it forever, but just filtered out for the next day or the next week or whatever. We can tell you what the nature of the attack was. Was it cross-site scripting? Was it SQL injection? What kind of cross-site scripting was it? Where in your application was it attacking? Which application was it attacking? And which endpoint URL was it attacking? Right, when did it happen? Of course, you get a timestamp. And so you get all this very nice stuff that shows you here's all the requests coming in. I know it's really hard to see. This is what it looks like. Basically, we give you a really nice blob of information that shows you, well, I can probably just pull it up in a browser. Maybe. Live demos, it's always a risk. Oh, you know, maybe my, I have to relog into the Wi-Fi, 1 second. All right, so here's Splunk. We've written kind of a Previty dashboard that goes through and looks at all the data that's being sent from our plugins and different servers. Of course, this is all just running on my laptop. And so once it loads, you'll get to see for every attack that comes in, hey, this person sent me this thing that had a script tag inside of it. It was this IP address. Because Previty was running in protect mode, we actually sanitized the input. So in this case, we stripped out the script tag. So this is what our filter took this input and gave this output as the input to the next filter. All right, it happened on this URL. It was this session ID, so we know a user was logged in. We give you all this information. Same thing for SQLi, okay, SQL injection. We can show you this person, in this case, tried to run a tautology attack. We can see here where empty string equals empty string. We can show you the stack trace inside of your application code where it happened. So you get all this really nice instrumentation. Of course, this thing can bubble up, and you can find out which IP addresses have been most malicious towards me. This is like a group by query. Which are the top endpoints in my application, which are most under attack. This is a simple single-page application that just has one endpoint. But that's the nice thing. Instead of just solving the problem by encoding, we can give you insight into all these things. So we talked about that before, about what if you were faced with a decision, and so I have these 10,000, let's say you're a CISO of an organization, Chief Information Security Officer of an organization, and someone says, you know, we need to solve these, we have this remediation backlog that has thousands of things in it. Which application do we start with first? This can help you to decide, well, these applications are actually under attack, so we're going to start there. All right. That's how people are using our stuff. And of course, because our stuff is deployed and actively blocking things, you're closed during that remediation gap. So from the time that you publish the vulnerability to the time that you fix it, Previty's blocking the attacks as they're happening. All right. Now the difference between us and a WAF is that we just do things differently. For us, there's no pattern matching. What we did, instead of saying, well, let's apply these regular expressions to look for something that looks like JavaScript, which, as we know, is very hard to find, what we did is we virtualized the browser. So we created a headless virtual browser that we can pass content through and ask it, would any of the browsers out there see this as JavaScript or not? It's not running it through a regular expression. It's actually, imagine if you just took Chrome and said, hey, here's a bunch of stuff. Is there anything in here that you would run as JavaScript? All right. So that's what we did, was we went and decompiled Chrome and Safari and IE using tools like IDA and Hopper to figure out how are these browsers actually parsing content differently. How do they parse content? How do they interpolate it into the DOM? They all deal with things differently, and it's one thing to talk about, very readable strings that look like this, but when you start getting into Unicode character sets and how browsers interpolate this Unicode character back to this other thing, they're all done differently. All right, so that's what we did. So well, let's create a virtual DOM that we can pass content through and ask the DOM, is there JavaScript in it? So because there's no pattern matching, that means there's no way to fuzz around our tool. Basically, if our tool sees it as JavaScript or sees something inside of it as JavaScript, one of the browsers at least would see that thing as JavaScript. All right, that's the idea. No fuzzing, no false positives. It's just this is what we've got our first few patents for. All right, no one else can do this. Yeah.
So if you create a testing environment, let's say you're building a layer that's basically dumping stuff into the storage or the database, and you want to make sure your SQL servers, you can just dump the code into that tool and they can see where there may be some vulnerabilities, maybe you need to patch this up, or you just test it. It's like kind of testing in the virtual browser.
Well, this is what we, yeah, so when customers have us come on site, we'll go through their database and say, let's just look at every field inside of your database and pass it through this and say, do you have any stored XSS? We can do that. And it's pretty easy to get a website to store XSS by using fuzzing. Right? If they're not escaping things properly. Right? We talked about encoding them. If they're not doing that, it's pretty easy to get a browser to store XSS. All right. I could show you a live demo of a big retailer that has an open XSS vulnerability, but I won't. Not while I'm being recorded.
What's the best steps to kind of avoid this from the beginning? I always feel like if we ask them my questions up front, you avoid all of them.
Yeah, well, that's what people build into their processes. Make sure you're doing static scans. Make sure you're doing dynamic scans. Make sure you do this encoding properly. All right, it's just a lot of things to get your arms around. So that's why you have information security organizations who try to develop best practices, and then they go out and train the development team inside of a company, right? But even within a big company, every development team is somewhere different along this sort of maturity path in terms of what they're doing. No way around it. So the best you could do is try to develop best practices, make sure they have access to the tools that they need, everybody's trained, and make sure that they understand it's important. Because like I said, security, well, it's sexy when you hear about it, because someone got hacked and someone shut down someone's car, but when you're working on it, it's really not glamorous. It's kind of like, it's not that fun. But you have to do it. You have to do it. So that's how we do XSS, is this sort of virtual browser. We do the same thing on the SQLite side. What we did was we took all the major SQL databases of MySQL, SQL Server, DB2, Oracle, and we reverse engineered their grammars, basically. We reverse engineered their query planners. So we have virtualized the query planners of those databases. So instead of just saying, well, I'm going to take this SQL query and pass it through, and I'm going to look for strings like 1 = 1. I'm going to look for strings like 2 = 2. We actually we do a full parse tree of that query. So we know, is it a select query, an insert query, an update query, etc. We know, is it an administrative query like adding a user or dropping a table. We mathematically evaluate all of the statements inside of it. So 3 = 2 + 1 gets mathematically evaluated by us, and we know it's a tautology. All right, there's no fuzzing around a pattern here. We do the mathematical evaluation of everything in it, and so we can detect every type of tautology. All right, so that's the same idea. We virtualized a browser here. Here we virtualized the database query planner, and so that's how we do stuff there. All right, so I'm happy to go more in detail on that afterwards if anybody wants to. Frank knows me from my last company where I was a solution architect at MongoDB, and that's where we met. So this is my job. I mean, I basically go around New York talking with customers who want to use our product and demoing it to them and going very in-depth and running proofs of concept. So if you want to talk to me later about maybe trying Brevity, it's free actually. We give you the monitoring tool, not the protection tool, but the monitoring tool. If you want to deploy that inside your Java application to find out, are you under attack, you can do that for free right now. You don't even need to ask me. You just go to our website and sign up. All right. But most people work in big companies. They don't understand the technology, how it works. How would we qualify it, do a proof of concept? And so I'm happy to do that anytime. Yeah. Thank you. This is where this is where I was going to give away a quadcopter, but now I'm going to keep it for myself. Right? I told you I was going to email you, so none of you will know if I actually do that.
What was the URL again for people that?
Yeah, I'll put the URL up. Please just, you know, be cool and like don't share with your friends, because you know I'm not going to know if they were here or not. But just for yourself, info.privacy.com/win. And if you win, I'll email you. You can give me your address, and I'll ship it to you. Okay. All right. Thank you very much.
Thanks. Any other questions?
So if I understand correctly, it's at the web app filter that actually intercepts all the inputs.
Yeah. So our code.
Provides,
Our code's running on your web application server.
right, and then basically it does prevention in case it's enabled, or otherwise it just logs to a log file and then you Splunk it out.
Correct.
So does it require any additional Splunk licensing or anything?
No, well, it's not just Splunk. So we'll log to any SIM, like whether you're using ArcSight or QRadar or whatever. Splunk accepts JSON format stuff. ArcSight accepts a format called SAST, complex event format. IBM's tools accepts a format called Leaf. So we logged all of these different formats depending on what your SIM is. It doesn't. If you have Splunk already, you don't need to pay extra for Splunk. Basically, you just go to the Splunk marketplace and download our dashboard and install it into your Splunk. Yeah. Yes?
So does it plug in and operate within the same JVM instance?
Yeah. Basically, you just take our jar file and you add it to your WAR file or your EAR file, and it just becomes part of your program.
Can you also set it up to operate as like an inter-process mediary, like to operate in between? Say if you have a JMS layer or a caching layer or something? Or persistence layer?
I mean, if it's using the request response framework, you could put it anywhere as long as it's using the J2EE request response framework. But we'd like to be right there on the app server, just because then we have access to the session object and we have sort of context of the application as well.
Have you done any performance analysis on this one?
Yeah, definitely. I mean, our parsers, we're basically writing our own HTML parsers and JavaScript parsers and SQL parsers. It's a forward-only parser. So unlike a regular expression, which can go backwards and get in loops, and I know we don't like to think about it, but there's actually a denial of service attack that people run against regular expressions. You could just Google regex DOS and you see what I'm talking about. So ours does never loop back on itself. It's a forward-only parser. It's very fast. Basically, depending on what you're doing, if you're just analyzing like a query parameter or a post parameter or something, you're looking at something in the range of 10 to 20 microseconds. It's all sub-millisecond. More complicated SQL queries we pass through when we're performance testing. We'll take like 100 queries with 100 nested subqueries with 100 joins inside of that. Something you would never really do in real life. But that gets up into the 60 to 80 microsecond range. It was fast.
Yeah, I was not able to understand how or where you intercept and analyze the SQL query part.
The SQL query part, you deploy a Java agent. So we have two jar files. One is a filter that does the request response lifecycle. That does XSS and CSRF protection. And then you have a Java agent that attaches using the instrumentation API. And we go and we look for where you're running the execute SQL execute query. I can't remember the name of the function in Java. But we look for that specific function and we use the instrumentation API to wrap that specific function. So every time you call that, your code calls that, basically your SQL query is going to get diverted to Brevity first. We'll analyze it. If we see something we don't like, we'll just raise and accept it. All right. There's no way to sanitize it the way you can sanitize JavaScript out of a post parameter, for example. So we just raise an exception and you can deal with that like any other database exception. Okay. Good.
Thanks a lot, Chad.
All right, thank you.